So up to now, whatever we have discussed about transistors and bipolar transistors was about them being biased in the active mode or in the linear region or the active region, meaning that, so we said the condition for the active mode of operation was that VBE being greater than 0 and VCE being, VBC being less than 0. Okay, so meaning that the base emitter junction, the PN junction between base and emitter, is forward biased, and the base collector junction is actually reverse biased. Okay, so for example, for a circuit that is shown here, let's say that I choose VBE, or well, the base voltage to be 0.7 volts to turn on the transistor to have a nice forward bias for the diode between base and the emitter. And let's say that I choose VCE to be 1 volt. Okay, that means that I have a VBC that is negative 0.3 volts. Okay, which is good because that means that the collector has 0.3 or 300 millivolts higher potential than the base. Therefore, the PN junction between base and collector is reverse biased. And then when we were talking about the active region current of a transistor, we said that, well, the current is actually generated because of this forward bias PN junction between base and emitter, and that's why it's exponential. And then all these electrons reach the depletion region between base and collector, and because of the electric field in the depletion region, they're shooted to the collector side, and then that's why I have a current. Okay. Now let's see what happens if I start reducing this collector voltage. Let's say I bring this collector voltage from 1 volt to first, let's say 0.7 volts, right? So I bring it down to the same level as VB, right? So let's actually show it with a different color. So we go to 0.7. So this becomes 0 volts, right? So what will happen to my transistor? Actually, not much. Why? Because, well, this PN junction that I had between base and collector here is not reverse biased anymore, but it's at its equilibrium, right? And we know that at the equilibrium, we still have a nice depletion region there. Therefore, more or less, the transistor is actually operating in with the same kind of principle of operation. So I still have my nice exponential expression for current of the collector. So collector current is still Is e to the power of VBE over VT. And for now, just forget about early effect and all that, right? We're just trying to focus on the saturation region and what happens when I reduce the collector voltage. Now, the other thing that I can still say about my transistor is that IC is still beta IB, meaning that the holes that are coming into the from the base emitter and going all the way to the from the base terminal, sorry, and then going all the way to the emitter are, well, they're 1%, let's say, of the electrons coming from the emitter to the base and going to the collector. So the base current is like 1% of the emitter or like 1% of the collector current. So we still have a nice large beta here. Okay. Now let's reduce this collector voltage a little bit further. Let's say that I go from 0.7 to 0.5. Now this 0 volts becomes 0.2 volts. Now the base collector junction is not reverse biased, or it's not at the equilibrium anymore, but it is forward biased by 0.2 volts, right? But by our discussions up to now, you should know that for this exponential thing that we have discussed, 0.2 means somewhere around here, right? We needed like at least somewhere around 0.7, 0.8 volts to actually have a reasonable, decent amount of current coming out, flowing through this PN junction, right? So for 0.2, the kind of current that I have is still pretty small, right? So, but I do have a new term for this current, right? I'm gonna have a new term of current, sorry. I'm gonna have a new kind of a element into my base current. So there was part of base current that is going to the emitter, and now I have a new kind of a base current that is basically the holes that are actually going from the base to the collector, right? So now, since the ratio between IC and IB was beta, I can somehow say that my beta is kind of reducing at this point, okay? What will happen if I actually continue doing this VC reduction? So let's say I go to something very small. Let's say I go to 0.1 volts. So this becomes 0.6 volts. Now I'm close to that 0.7 that I know that is going to cause a huge amount of current. Now I know that I'm fully, my transistor is going to act very differently, because I'm going to have this term of my base current is actually increasing very rapidly, right? And then I can now, with a lot of confidence, I can actually say that my base current is not really much smaller than my collector current, right? Because now I have two forward bias junctions, one between base and emitter, and that is causing all these electrons traveling from the emitter to the base. And now I know that a lot of holes are actually coming to the base, and they might actually recombine with these electrons. But let's say that because of the thickness of the base, because of, well, let's say lack of thickness, the thinness of the base, this recombination is still not a lot, and a good portion of these electrons actually reach to the collector. But at the same time, I know that I have this major current going from the base to the collector as well, due to the forward bias of the PN junction between base and collector, right? Because of all of these, I cannot really say that's basically, I'm gonna analyze this in the next few slides, but we are gonna see that a lot of these equations that we have had up to now relating the currents in different terminals are not valid anymore, okay? In terms of terminology, once we actually get to a little bit of, like, once we get to the equilibrium or a little bit of forward bias for the base collector junction, we say that we are in the soft saturation region, right? And then once we actually decrease the collector voltage to very low values, so that basically the base collector is completely in the forward bias, we say that the transistor in the saturation region, okay? So when collector voltage drops below base voltage and forward biases the collector base junction, base current increases and decreases the current gain factor that is called beta, okay?